Alright, section 8.3 looked at a bit more complex graphs, rational graphs. So the first one says 8 divided by x squared minus x minus 6. So again, to find the vertical asymptote, you solve the denominator. So I'm going to set, actually I'll just set that denominator equal to 0. Of course it's a quadratic, so lucky for us that factors down to x minus 3 and x plus 2. So I'm going to have vertical asymptotes if I solve those at 3 and negative 2. So I will plot those. So 3, I'm going to have an x-intercept at 3 and at negative 2. So there's those two vertical asymptotes. And my end behavior asymptote, because the degree on top is 0 and the degree on the bottom is 2, the degree on top is less than that of the bottom, so I know that my end behavior asymptote is simply going to be y equals 0, so I'll draw that in. And rule of thumb, however many vertical asymptotes you have, you're going to have one more pieces of graph. So if I have 2 vertical asymptotes, I'm going to have 3 pieces of graph. So I better test some points to the left of this vertical asymptote, in between the 2, and to the right of the last one. But first I can find my x-intercepts. So if I plug 0 in for y, then my denominator, when I multiply it over times that 0, it's going to wipe out, and I'm going to have 0 equals 8, which tells me I have no x-intercepts. My y-intercept, if I put 0 in for both x's, I'm going to have 8 over negative 6, which of course is negative 4/3. Or negative 1 1/3. So that's a free point. I can kind of plot that right here. So again, I would test some points to the left and to the right of each extreme vertical asymptote, and then maybe a couple in between. So you have to test a few more points to get a good idea of what this will look like. So maybe I'll test negative 3 and negative 4. And then, let's see, I already have 0, so maybe I'll do like 1, negative 1, and 1 in between, and then maybe I'll do 4 and 5 to the right of that last vertical asymptote. So if I put negative 3 in, negative 3 squared is 9. 9 minus 3 is 6. Wait a second. Negative 3 squared is 9. 9 plus 3 will be 12. 12 minus 6 is 6, and then 8 divided by 6 is 1 1/3. Negative 4, that would be 16 plus 4, which is 20. 20 minus 6 is 14. So 8 divided by 14, and I'm just going to kind of approximate that. That's about 0.57. Negative 1, let's see, negative 1, that'd be 1, plus 1 is 2, 2 minus 6 is negative 4, 8 divided by negative 4 is negative 2. Positive 1, 1 squared is 1, minus 1 is 0, negative 6, so that's going to be negative 1 1/3. 4 squared, 16 minus 4 is 12. 12 minus 6 is 6. And 8 over 6 is 1 1/3. A lot of 1 1/3s here. And lastly, 5 squared, 25. Minus 5 is 20. 20 minus 6 is 14. 8 14ths again, so that's that 0.57 estimate. So if I just plot these, kind of get a feel for where I'm at. Negative 3 and then 1 1/3. Negative 4 and roughly 0.5. Negative 1, negative 2. Positive 1 and negative 1 1/3. 4 and 1 1/3. And then 5 and about a half. So I can really see that I'm going to have the hyperbola branches here, and then I'm going to have kind of a parabolic piece here because it's rising up and going down. So if I put my hyperbola branches in there, make sure right along my asymptotes, I can see my domain is everything except 4, so all real numbers except x cannot equal 3 or negative 2, and my range is all real numbers except y cannot equal 0. Alright, this one, a little trickier. My vertical asymptote, I will solve that denominator, so that's not too bad. X equals -3, and again, I would draw those in as soon as I find them. The end behavior asymptote, because my degree on top is larger than that of the bottom, I have to divide it out, so thankfully I can do synthetic since I'm dividing by a nice linear expression. So the coefficients of my numerator expression are 1, 2, -8. 1, 2, and that's a 2, sorry, and -8, and then I'll divide by the solution of the denominator, so that's -3. So carry down, then you multiply these, add, multiply, and then I don't care about that remainder, but I know my end behavior asymptote will be y equals x minus 1. So let's see, -1 with a slope of 1, and I just kind of plot those points, and that basically is your end behavior asymptote. So that's kind of that slanted asymptote. X-intercepts, of course, if I plug in 0 for y, this will wipe out, so you always end up solving that numerator, So that factors down to x plus 4 and x minus 2, so I'm going to have x-intercepts at 4, and if I solve those, right, 2, so -4 and +2 will be some points that I have. That's nice. Y-intercept, of course, if I plug in 0 for all the x's, so that's 0, so I'm going to have -8/3 left. And so that will be -2 and 2/3, so I'll kind of plot that point. And then you can kind of see that you have probably a graph piece going like this, because you have to follow that slant asymptote, and your other piece is like this, so maybe just a few more points, but this worked out well for us. Maybe like -5 and -6 you could test. You could also test like 3 or 4 if you needed to test all of those points. And then I'm going to do these kind of quickly. -6 is -5 and 1/3, and you can pause the video and check that you can handle this. -5 is -3.5. And then 3 and 4, 3 is 1.2 and 4 is 2.3. So if I graph those, -5 and then -3.5, -6 and -5 and 1/3, I really can see that piece there. And then 3 goes to about 1.2 and 4 goes to about 2, so yeah, it's just kind of riding along that asymptote. Perfect. And then your domain, again, is all real numbers except that vertical asymptote, so x can't equal -3. And then the range is everything, because this goes on forever in both directions for the y values. Alright, the last graph, if I solve the denominator, that factors down to x plus 2 and x minus 2, so when I solve those, my vertical asymptotes will be at 2 and -2. So again, I would draw those in. My end behavior asymptote, the degree on top is less than that of the bottom, so y equals 0. And my x-intercepts, if I plug 0 in for y, the denominator always wipes out, hence I'm solving the numerator. So if I set 2x equals to 0, I obviously get 0, 0 as an x-intercept, which is on my end behavior asymptote, and that's okay. Remember, you can cross through on behaviors as long as in the ends approach those asymptotes. And lastly, my y-intercept, if I put 0 in for this x and 0 for this x, I'm going to have 0 divided by -4, which is still 0, 0. So I have 2 vertical asymptotes, hence I'm going to have 3 pieces of graph, so I better test enough points to get an idea for what it looks like. So I would probably do -4, -3, -1, +1, and then maybe 3 and 4. So when you plug -4 in, you get -2/3. When you put -3 in, you get -1.2. -1 is 2/3. +1 is -2/3. 3 is 1.2, and 4 is 2/3, so kind of a reflective thing going on here. So -4, -2/3, -3 and 1.2, -1 and 2/3, 1 and -2/3, 3 and 1.2, and 4 and 2/3. So again, I can kind of see the hyperbola branches here in the left-hand corner and the upper right-hand corner, and then in the middle is kind of that cubic type of graph happening. So my domain is all real numbers, except x cannot equal ±2, and my range is all real numbers because that cubic piece in the middle crosses through my end behavior asymptote.